Thank you for joining us. In our topic today, we'll be looking on composite functions and the inverse of composite function. All right, so we're going to start off with two functions, and then we're going to find the composite of them and the inverse as well. So we have our function f and our g function, and we are asked to find f of g. What this means is our f function, which is our 2x plus 1. Right, in order to, we're going to substitute our x, in which we are going to input the g function into the f function. So we have our f function on the outside, and our g function will be on the inside, which is x squared plus 5. Right, see our f function, and we're substituting our g function inside of the f function. What this will be is 2 times x squared, 2x squared plus 2 times 5 will give us a 10 plus this 1. And so our answer will be 2x squared plus 11. Alright. Looking now on our g of f of x. Alright, so our g function, which is x squared plus 1, for x will be the main function in which we will square it, and we will substitute our f function into our g function. So our f function is 2x plus 1. And we see this is being squared. So easiest way to do this is to write our bracket squared, and this will be plus 5. Right? With everything in this bracket being multiplied by everything in that bracket. Right? So first we will have 2x times 2x will give us 4x squared, and then 2x times 1 will give us a 2x. 1 times 2x will give us a 2x, and a 1 times 1 will give us a 1. And we add this 5, that's 5. In wrapping up this now, we will have 4x squared plus 4x plus 6. And as we are well aware, we know that our f of g is not equal to our g of f. We will now look on the inverse of a composite function. And in finding inverse of a regular function, same procedure that we will find the inverse of a composite function. All right, so we are to determine f inverse, g inverse of x. We know it's a process to find our f inverse, but we are now going to find a composite form of f inverse and g inverse of x. We're going to find it when our x is equal to a -2. We're now going to find our composite form of f of g, find the inverse of that as well, and f g inverse when x is equal to a -2. All right, so we are going to write our f function, and then we find the inverse of it. Okay, so we have 3x plus 2. The first step in finding inverse of a function is to define the function where we're saying y is equal to 3x plus 2. Our next step is to interchange the x for the y and the y for the x. What we will have our y being x and our x being y. And now for inverse, when we see we have 3 being multiplied by the y and then being added to the 2, we're going to start by doing the opposite of what we have. We see a 2 is being added. We're going to subtract 2 on this side. So do it on this side, so it'll be x minus 2 is equal to 3y. So it cancel. Our 3 is being multiplied by the y, so we're going to divide it. We're just going to kind of flip it and put a y on this side. So our x will be on this side. Alright? Sorry, over 3. So our f inverse is equal to 3 x minus 2 over 3. Alright. However, we're asked to find f inverse and the g inverse. So our g of x is equal to 2x minus 1. Doing the first step to find the inverse of the function is to interchange it. Well, let's define it rather. Y is equal to 2x minus 1. Then we do the interchange. X is equal to 2y minus 1. You see, 1 is being subtracted on this side. We're going to add it on both sides. We'll have our x plus 1 is equal to 2y. Let's cancel. Dividing 2 on both sides. Alright, so now we're going to flip it and say y is equal to x plus 1 over 2. So our g inverse is equal to x plus 1 over 2. The function asks us to find the f and g inverse of x. So we're finding our f inverse g inverse of x. Alright, and when we see that now, we know that we are going to find the composite form of this. So our f function, which is equal to x minus 2, and this will be over 3. And our g function, which is x plus 1, I'm going to put that in the function x plus 1, this is over 2. Right? So we input our g function inside of our f function. Our next procedure now, we see this being subtracted, this being divided. So what we are going to do now is to, let's try to give this some space right here. Right. So the first step now is to get rid of this 2 from the denominator. So let's just write it back right here. I'm going to multiply by 2 by 2. So we will have a cancel. We will have a x plus right plus 1. Try and get some eraser. All right. All right. So here we are. Over x plus 1 2 minus 4, and that will over 2. These three now, we are going to find a reciprocal of that, and then we're going to times it by I being divided. So we're going to times it by 1 over 3. And what we have here, so we have the 1 minus 4 is equal to x minus 3, right? And this 2 times 3 will give us a 6. And the inverse now, in which we got this 3 from the denominator by multiplying it by the reciprocal of it, which is 1 over 3. This 2 now, we multiplied it by a 2, and multiply this negative 2 by a 2 to get a negative 4. And we replace it over 2, and that 2 will be multiplied by the 3 to give us the 6. So our f inverse, g inverse of x, is equal to x minus 3 over 6. The next step had said that we should substitute our x to be equal to a negative 2. X will be negative 2 minus 3 over 6. That's equal to a negative 5 over 6. All right. Equal to 5 over 6. Oh, the whole function will be negative. Okay, so the third section now is where we are going to find our f of g inverse. All right, so the third step was to find fg, and then we are to find the inverse of that. All right, so let's get some more space. we have our f function, which was equal to 3x plus 2, and our g function, which was equal to 2, 2x minus 1. So we are just going to input the function, right? I'm going to find the inverse of them first. We're asked to find f will be our main function. Of g of x. So f function is 3x plus 2, and it's 2x minus 1. We're going to input our g function inside of it, which is 2x minus 1. And we will have a 2 times 3, 3 times 2, 2x, 3 times a negative 1, and negative 3, plus 2. And so it will be 2x minus 1. So we have our 2x minus 1. Then it asks us to find the inverse of this. Alright? So this will be our f of g. So to inverse this, we define it. So y is equal to 2x minus 1. Interchange the letters. X equal to y minus 1. Alright, so we have a x subtracted plus 1. We add 1 equal to y. Right. Then we divide it by 2. And so we have x plus 1 over 2 is equal to y. So therefore our f g of x inverse is equal to x plus 2, sorry, plus 1 over 2. Alright, so what we did first was to find our f of g, which we found the composite form of f of g, and we were then asked to find the inverse of that. For the first example that we did, we found the inverse of the function of both functions, and we substituted or found the composite form of them. Alright, so right here, this one here seems to have made a mistake. This would have been 3 times 2 would have been 6. Alright, so we would have 3 times 2. Yeah, this side here I need to change as well. Alright, 3 times 2 would give us 6x minus 3, 6x minus 1. Alright, we were able to catch that mistake. Alright, so let's try to rewrite our 1 properly. And the answer then is x plus 1 over 6. All right, our next fourth part was to substitute the value of x is equal to -2. After we did this part, where we are, where? So we are to find f of g and x is equal to -2 and the inverse. So this was what we found, right? We had already found our f of g inverse, which is equal to x plus 1 over 6. It asks us to substitute x as -2. So we have a -2 plus 1. That would be a -1 over 6. So f of g, -2 inverse, is equal to -1 over 6. And that would be how we accomplish. Let's look, however, on a few more examples. A function f Okay, so we are asked to find f of g, which is our f function, which is 3 minus 2. We're going to substitute our g function, 2x plus 5, c2 6x plus c5 15 minus 2. So it's 6x plus 13. That would be our f of g. Our g of f inverse. Alright. So we need to find our g of f, then we find the inverse of that. So our g of f, let's have our g function 2 and our f function is 3x minus 2. Let's try to erase that before. 3x. What we will have is 2 times 3, 6x minus 4 plus 5. So we'll have a 6x plus 1. We were then asked to find the inverse of that, which would be our g of f x inverse of 6x plus 1. We are going to define it. Y is equal to 6x plus 1. So x is equal to 6y plus 1 minus 1. So x minus 1 is equal to 6y. Divide both sides by 6. Our g of f inverse is equal to x minus 1 over 6. Alright, we are now finding our f inverse. So we start off with our f function. F function is 3x minus 2. We're going to find the inverse of that, then we're going to substitute it. Defining it, y is equal to 3x minus 2. Interchange the letters, x equals 3y minus 2 plus 2x plus 2 equals 3y divided by 3. Our f inverse would be x plus 2 over 3. We're going to find our g inverse. Our g function was a 2x plus 5, and so y is equal to 2x plus 5. Interchange letters, x is equal to 2y plus 5. Doing the opposite, minus 5, we have a x minus 5 dividing by 2, y is equal to that. However, we are now going to find the composite form of f g of y. So our f inverse g inverse of x is equal to, we found our f inverse function, which is equal to x plus 2 over 3. So for the x, we're going to substitute our g inside of that. So our g will be x minus 2 over 5 plus 2 over 3. Alright. And what we will do here is to, all right, we see our 5 is being divided. So we will we'll multiply this by 5, multiply this 2 by 5 as well. And so we will have a 2, sorry, x minus 2. This 2 times 5 will give us a plus 10 over 5. This 3 now, we're going to multiply it by the reciprocal of 1 over 3. So it will basically eliminate that denominator right there. Right. And our next answer will be a x. This minus 2 plus a 10 will give us a positive 8. This 5 times 3 will give us a 15. Right? So that will give us our answer. We were then asked to find f inverse g inverse when our x is equal to what again? When our x is equal to a negative 2. X is equal to a negative 2. Because we already found it to be x plus 8 over 15. Substituting our x as negative 2, we find it to be a 6 over 15. And so our f inverse g inverse, now x is equal to negative 2, is equal to a 6 over 15. All right. So you can